Hi guys, I am Muchekwa Ellen Tangeni with Maths XYZ, and in this lesson we'll be continuing on doing more example on the effect of different compounding period in financial mathematics. In the previous lesson, when we introduced the effect of different compounding period, I still introduced you to those three equations, which the first one is the compound growth, and the second one is the compound decay, which is also called the reducing balance method. Alright, so here we have a question which says that Rose invested 7,000 into a savings account for 4 years. So this is the most important. Save 7,000 for 4 years. If the savings account offer an interest rate of 7% per annum compounded monthly, okay, let me just use a red marker. This is 7% compounded monthly. Determine how much you will have after 4 years. So here we have Rose who has invested 7,000. 7,000, we know that if it's the initial amount, then is the principal, which is equals to P. And then for 4 years, that means that that's our period, which is equals to N. And the interest rate is 7%, which is I. But then they continue to say that it has been compounded monthly. That means that we have to divide the interest rate by 12, since we have 12 months in a year. And we also have to multiply the period by 12 because it will be compounded for 12 times in a year. Then here we have our equation, which is A is equals to P into 1 plus I into the exponent of N. The reason why we use the compound growth method equation is because that this investment is actually a gain, that they didn't tell or mention anything that this investment will depreciate over time. That's why we use this one, where the investment will grow with time. Then here we have 7,000, which is our principal value, into 1 plus our I, which is the interest rate. It's equals to 7%, and then divide by 12, which is the number of times that this interest rate will be compounded annually. And then here we're going to have 4 years, and then multiply by 12, because the investment will be compounded. It will be calculated each and every month for 4 years. Then here we just punch it into a calculator, and we'll get 7,000 into 1 plus 7% divided by 12 into an exponent of 4 multiplied by 12. 4 multiplied by 12, of which this will give 9,254.38 cents. That means that after 4 years, when Rose goes to this account, it will be worth 9,000. The 7,000 will have increased to 9,254.38 cents, which is actually she would have gained 2,254 from the initial investment that she has made. So this investment here is actually a gain, because she has gained an amount which is above 2,000 rands. Then let's go to the second question here, which says that the investment grows from 6,700 to 8,510.59 cents in 3 years. Determine the interest rate received if the interest was compounded monthly. So it is the same, it's still the same thing, that we are finding an interest rate which would be compounded monthly, and then they are asking what is that interest rate. In this case, we are actually given all the parameters beside I, which is our unknown, which we are looking for. Then here we have A is equals to P into 1 plus I to the exponent of N. You use this equation because the investment actually grow from 6,700 to 8,510. That means it's actually a gain in the investment. So that's why we have to use the compound growth equation. Then here we have 8,510.59. It's equals to our principal value is 7,600 into 1 plus our I, that's what we're looking for, and it should be divided by 12. Remember, this thing is compounded monthly. That means that it will be compounded 12 times in a year, because we have 12 months in a year. And then here we have our N, which is equals to 3 years, and we also have to multiply our N with 12. Then to get our interest rate, which is our unknown, we will divide both sides with 6,700. Divide both sides with 6,700 to get that, and that to cancel out, and then we'll have 85110 I mean to say, comma 59 divided by 6,700, which will give us 1,2. I'll write the side, which will give us 1,27 going on and on. With financial mathematics, it is very advisable not to round off when you are still working on the answer. You can only round off to 2 decimal places in your final answer so that it will be more accurate. So this 1,27, I will store it in B, of which if you are using a casual calculator like mine, what you need to press is Shift and then store, and then press any alphabet. It can be either A, the alphabet are written in a pink color, so I will just choose A. So I have stored this in my A. So here we have one, and then after that we're going to have one that is equals to 1 plus I divided by 12 multiplied by 3 multiplied by 12. It will actually give us 36. Alright, then we just have to introduce the 36 root, which is 1,27 there, and there is equals to 1 plus I over 12, of which if we introduce the 36 root, it will be just left as 1 plus I divided by 12. Then here we are going to have that, which is 36 divided by that into that. That will just give us, that will give us 1,0066 going on and on, of which I will still store this at any of the alphabets. So it will be Shift, recall, and then I will store it at B. So that's alphabet B. It's equals to 1 plus I divided by 12. So now to have 1 plus I divided by 12 as our subject to the formula, then we just have to subtract 1,00, this one that we have there, minus 1. So this minus 1, it will actually give us 6,66 times 10 to the exponent of negative 12, which is I divided by 12. This multiplied by 12, now it will give us I is equals to 0,08. And remember, the interest rate is in percentage, so I have to multiply this by 100, of which it will give it's equals to 8%. So for the investment to move from 6,700 to 8,810, 8,510, I mean to say, 59 cents in 3 years, and if the interest rate is compounded monthly, what you will get, the interest rate must be 8% for that to happen. Alright, I need you to take into consideration some of the things we did here, that if it's compounded monthly and you are looking for the interest rate, never forget to multiply by 12 there, and never forget to divide the interest rate by 12. For in case if it was compounded semi-annually, then here would have divided by 2 and would have multiplied the period, which is n, by 2. Then you must always remember to divide by 12 and also to multiply by 12, because when you get to the final answer, if from here, from the 6,66 multiplied by 10 to the negative 12, if I just multiplied by 100, it wouldn't have given me the correct interest rate which is needed for this case. Alright, I hope you guys understood this question, and if you have any question, please just put it in the comment note, and then we'll get back to you with better explanations. Alright, please don't forget to subscribe to Maths XYZ channel on YouTube, so that when we upload videos, you will always get the notification. Alright, bye. Thanks guys.